Hello everyone. In this video, we are going to study projectile motion. The projectile is a kinematics in two dimensions, and we are going to continue with our knowledge from the previous video on kinematics in one dimension. So we will look at first scenario where a projectile is launched horizontally. So in this horizontal launch, you will see that a projectile takes a curved path, and if I draw a different points at, you will see that since there is an acceleration in the downward direction and there is no acceleration in horizontal direction, if I resolve the velocities into two components, you will see that the horizontal component of that velocity won't change, but the vertical component of the velocity is increasing because of the gravity. So this is something that we need to remember. And the projectile always follow the path of the resultant of these two velocities. So here we will make our table for the SUVAT SUVAT, and I will always I like to name those 2 points that I am referring to my initial and final point. So A to B, and since there are this motion in two dimension, I will take X direction and motion in Y direction. Now in motion in X direction, if I'm taking the displacement in X direction, let this be a range that maybe they can ask. So that is R, and Y is the horizontal displacement, that will be my H. Okay. Now in this case, the displacement is downward. I can take this as negative. The initial speed in X direction is U, while it is zero in Y direction, because that the initial, when it is horizontally launched, it only have horizontal component and no vertical component of the initial velocity. Now with time, the initial velocity in the final velocity in X direction will remain same, while the final velocity in Y direction will change. Let it be some Vy. Okay. And acceleration in X direction will be zero, because there is no acceleration in horizontal direction when the air resistance is negligible. And this is G. I will take it as minus G. And the time period, the time taken for the entire flight, let it be T. Now from this equation, we can quickly derive all this points. So if I use those equation in Y direction, let's say I need to figure out three important key, like what is R, what is the velocity at the final point B, velocity at B, and then we have to find the time. So, so in that case, in Y direction, if I use V square U square plus 2AS, so final velocity will be Vy square, initial velocity will be 0, and this will be 2G minus G and minus H. So I will get my Vy to be square root of 2GH. Okay. And similarly, I can get the time T by using S is equal to UT plus half AT square. And where I can get displacement is H is minus H, and this will be U is 0 in Y direction. It is half, this is minus G, and there is T square. So from this, you simplify, you will get T is equal to, so T is equal to 2H by G. So the time period only depends on what is the initial height and the phi and the gravity. So this is the time that it will take. This is the Vy. This is not a final velocity, because final velocity will have two components, like the horizontal component that will be U and the vertical component that will be Vy. Okay. Now, if I want to find the range, I need to take in X direction. So in X direction, I can take S is equal to UT plus half AT square. Now, since acceleration in X direction is 0, you can see from the table, and the displacement is R, the initial speed is U, and the time is t. So this can be written as u into what we have just found, square root of 2fg. So this will help us give the range as well. Okay, we can find the final velocity by taking the resultant. So what we have is the velocity v, and we have horizontal component which is u only. For the final velocity, it won't change horizontal component, while the vertical component is vy. So v will be find the magnitude will be u square plus vy square. So that will be just square root of u square plus 2gh. So this is how we can get all the necessary values that we need. Now we can also plot a graph. If I want to plot a graph of the velocity, how the velocity is changing with time. If I want to plot, the velocity will be having an initial value. Okay, so if I'm plotting my horizontal velocity, let's say, it will be a constant at u, because it won't change over the period of time. Well, if I want to plot my velocity vy with respect to time, so that will be increasing with the time. So it is increasing at a constant rate. Okay, so it will be like this. Now, when we look at a problem where the projectile is launched at a particular angle, what we need to do initially is to resolve the vectors u into two components. The two cos, so in horizontal direction, this will be u cos theta, and in vertical direction will be u sin theta. And what will happen, since there is no acceleration in horizontal direction, and acceleration in y direction is r negative g. Now this projectile will reach some maximum height, let it be h, and it will also have some range r. Okay, so let's say for this particular problem, we are supposed to find what is the range, what is the maximum height, and how much the time of flight is. So in that case, I would like to break down this path into 2 to 3 different points. Okay, now A to B is the half part of the journey where it reaches the maximum height. So if I make a table from A to B first, S U V A T, and in x and y direction, I will get two values. So displacement in x direction, it won't be the entire range, but it will be half of the range. Then displacement in y direction will be h. The initial velocity in x direction will be u cos theta, and this will be u sin theta. V velocity will be, final velocity will be same in horizontal because it won't change, but at the top it will be 0, the vertical component of the velocity. So these are the small things that we need to remember. Acceleration is 0 and acceleration in y direction is minus g. Time period is the time period. I will take this as t dash. It is a half of the time period of the entire journey. So now using this equations, there are in y direction, I can see that I know u sin theta, I know g. So I can use an equation in y direction. So in y direction, if I use v is equal to u plus a t. If I use this equation, since the velocity is 0, because why I choose y direction, because I can see that I know multiple things in this particular column, and you only need 3 things. You can figure out the other 2 from the SWOT equations. Okay, so this is 0, this is u sin theta, this is minus g, and this is t dash. So I will get t dash is equal to u sin theta upon g. Okay, now I can also figure out the height by using v square u square plus 2as. Okay, now It is not that this is the only equation that will give you the height. You can use other equation also, and you will get the same answer. And v square is 0, and u square is u sine theta, the whole square, minus 2gh. So from this you will get h is equal to u sine theta, the whole square, upon 2g. And you should be able to derive those equations, because those equations uh, can be asked. This is the equation of maximum height. Now, if I want to find the range, I can take in x direction. So if I take my motion in x direction, I can use s is equal to ut plus half at square. Now you can see the time will be same in both the direction. And this range is half of the range, entire range. And u is the u sine theta, sorry, u cos theta in horizontal direction. And the time taken is t dash. So from this, I can see that if I substitute the value of t dash, I will get u cos theta times u sine theta upon g. So from this, I can figure out the actual range. The range would be 2 times of u square cos theta sine theta by g, or I can write by using some trigonometric identity u square as sine 2 theta upon g. So these are the factors the range depends on. Now talking about the entire time of flight, now that is also easy to find, because this is the half time, the time taken to reach maximum height. So the time of flight will be just twice of the time to reach the max height, and that will be 2 times u sine theta upon g. So this is how we derive those equations very much quickly using SOAT equations in 2 dimensions. Okay, so what we can do is also the graphs are also important. So we can use a graph, we can draw a graph of the velocity in x direction for this. So this will be a constant throughout the motion, the component of the velocity, while the component of the velocity in y direction will be such that it will start with a certain value and then it becomes 0, and then it will again increase in other direction. Okay, so this is how the graphs will look like. Now, if I want to do a scenario where the projectile is launched at a particular angle, now again the same procedure we need to follow. We need to break down this motion into a couple of points. So maximum height is this. So let this maximum height be some h. Let's say they have given me the maximum height h here also, and this is c, and I want to find what is the range r and what is the time of flight. So what I will do is, you can't solve directly from a to c. Okay, you can solve it, but it will require a little bit complex math. So what we can do is simply is to find the motion from a to b, find the displacement from a to b, let it be r1, and displacement from a to b, let it be r2. Okay, and we can break down the motion and find the total length in 2 points. So for that, what we will do, we will again make our table from a to b. Now this time I will do it very quickly. Again, here will be 2 components, u cos theta, u sine theta, and this will be displacement in x direction will be r1, the displacement in y direction is h, u will be the initial speed, so I will have u cos theta and u sine theta in the thing, and the final velocity is u cos theta, and at top it will be 0, acceleration is 0 here, and minus g. In this case, time period is, let it be t1 from here. Okay, so in this case I can find v is equal to, if I use in y direction, v is equal to u plus at. If I use, I will get 0 is equal to u sine theta minus g t1. So t1 will be u sine theta upon g. Similarly, if I use v square u square plus 2as, like the previous problem, I will get 0 u sine theta square minus 2gh. So from that, I can get h is equal to u sine theta square upon 2g. Now this is something that I got. I can substitute it in y in x direction also. I get r1 as, so if I use in x direction, s is equal to ut plus half at square. So you will get that acceleration is 0 here. So it will be just r1 is equal to u cos theta into t1. So we have got mostly everything, all the information. Now we will do from B to C. So from B to C, if I do, I will again make the table S U V A T, and that will be in x and y direction again. Now you will see that the displacement here in x direction will be R2, while for the total displacement in this direction, it will be h plus h. Okay, it is going downwards, so I will take the minus sign. Initial speed is 0, sorry, not u cos theta in this case, and 0 in this case. It will be same for the component because the acceleration is 0, it won't change. Let it be t2. And what will the final velocity? Something that we can figure out, that let it be v dash, and the acceleration will be minus. So again, I can use in y direction. If I use v s is equal to ut plus half at square. So this will be h plus h. Initial speed will be 0, and this will be half minus g, the t2 square. So from this I can get my t2 as 2h plus h upon g and square root of that value. Okay, so once we have got t2, we can use v is equal to u plus at in y direction. So we can get v dash as 0 plus g, and that is t2. So we can substitute that, and we will get a v also. Okay, now if I want to find r2, I just need to use another Sword equation in x direction. So that is s is equal to ut in x direction, everything in x direction. The acceleration is 0, so this will be r2. U is u cos theta, and the time is t2 here. So I can substitute t2 as 2h plus h into g. So you can see that we have got all the important variables. You can just find the total time as t1 plus t2. You can find the total range to be r1 plus r2. And the final velocity would be the square root of velocity in x direction and velocity in y direction components. In this, velocity of x direction will be u cos theta only, it won't change, while in y it will be v dash the whole square. Okay, so this is how we do the SWOT problems. Now one last thing I will add is, like, when air resistance is present, when the air resistance is present in a projectile problem, the projectile usually experience two things. So if the air resistance acts in always opposite direction of the velocity, okay, and if I draw what are the forces acting on this projectile, if the projectile is moving in this direction, the forces will be the weight of the projectile, and the air resistance will be in opposite direction. So air resistance will itself will have two components. One component, so if I have what horizontal component, the horizontal component of the acceleration will be the negative component of air resistance in the x direction. Okay, and you will see that in y direction there will be weight plus the component of air in this direction. So what we will see is that for this part from A to B, for a projectile, there will be more acceleration downward and there will be non-zero horizontal acceleration. So I will say non-zero constant horizontal acceleration from A to B, I'm saying horizontal acceleration we will see, and we will also see that there will be more than G, okay, greater acceleration value. So greater acceleration downward. So that's the reason why the projectile won't reach the exact height. Okay, if I just plot the path, it will reach less height in less time. Okay, uh, maximum height in less time. That's, and if you see that the projectile, if the projectile has at this point, if the velocity is in this direction, okay, then the air resistance will be acting in this direction. So air resistance will have two components now, air resistance in y direction and air resistance in x direction will be here, and the weight will be acting in this direction. So if I see forces in x direction, the way air resistance acting in x direction, and it will have to be constant, and if the forces in y direction, it will be weight minus force of air in y direction. So it will be less than g acceleration in y direction, and this acceleration will be decreasing, this acceleration will be increasing. Okay, so this will be increasing and decreasing acceleration, and this is in y direction. So vertical acceleration will be less than g because the air resistance is in opposite direction, and there will be non-zero horizontal acceleration, which will be constant. Okay, so what will happen to the path? The blue line is the path that I'm drawing. So path will be, it will have less range and less height, something like that. So this is with air resistance. We'll talk about air resistance in detail in forces chapter. So till now, you can see that all the projectile problems have been done. Thank you so much.